Hello class. I am now going to start the lecture for section 2.1. This section is an introduction to functions and relations and looking at some mostly definitions and the graphs of these things. So let's start with a relation. I left a little space on your handout so you could take some notes. Probably not enough space, but a relation is really something very general. For this class, we're mostly going to be dealing with relations with just two variables, usually x and y. And a relation is basically anything that will relate or define some kind of rule to relate an x value and a y value. So literally, it's just any list of ordered pairs. But a common relation that we're going to deal with in this chapter will be something that looks like this. X squared plus y squared equals 9. And it turns out if we graphed that, so first we could choose x values and plug them in and find the y values that went with them and find a bunch of ordered pairs that we could then graph. And when we graphed it, it turns out that this relation will give us a circle. So that's just one example of a relation. Basically almost anything that we deal with here that has two variables in it will be a relation. Now, the domain of a relation, or a function, as we're going to learn later, the domain is the set of all the x values that get used or can be used. So they're all the possible x values. That's what the domain is. And let me pause for a moment and we'll talk about range. Okay. So now, as I just said, the domain we think of as the set of inputs or x values, or those are often called the independent variables. Okay. Next, the range. The range is the set of all the y values that get matched up with our x's. So we often say they are the set of outputs, which usually are y values. And these would be called the dependent variables because they depend on what you put in for x. The y you get out depends on the x you put in. Okay, so there's some vocabulary. Numbers 1 and 2 are just asking you to give the domain and range of the relation. So remember, a relation can be anything. And in number 1, the relation is just this set of ordered pairs. There are 4 ordered pairs in the list. And when they say give the domain, they just mean list the numbers that are the x values. 1, -7, -3. Oh, there's another -3. We don't need to list it twice. Okay? When they say give the range, they mean list the y values. -8, 8, 7, and -5. That's it. So I'll leave you guys to do 1 and 2. Now we're going to talk about a function. A function is a special relation. Okay? So function is relation, but it's special because for every x value that you put into a function, you will only get one answer out for y. So let me say it again. For every x value or input that you put into a function, you will only get one output value. Now the output does not have to be unique. So for example, if I put 1 in to my function and I get out -5 for y, then I can put 2 into my function and also get out -5. So it's not that it's unique, it's that you only get one y every time you put an x in. Okay? So that's what a function is. 3 and 4, they're asking you to determine whether these relations are functions or not. I'll just tell you, number 3 is a function because every time I put an x in, so when x is 1, I get y is -5. When x is 3, I get y is 9. When x is 4, I get, and you just check them all. Whereas when you look at number 4, when x is -7, this ordered pair tells me that when x is -7, y is 5. And this ordered pair tells me that when x is -7, y is 1. So I have the same x value, -7, that gave me 2 different y values. So that is not a function. Okay? That is not a function. So I'll let you guys think about that. Next, we don't really deal with functions that are just lists of ordered pairs like this. We deal with functions that look like, equations that look more like algebra, right? Since this is an algebra class. So it says determine whether the equation defines y as a function of x. The way you want to do that is you want to solve for y and then see if anything weird happened as you're solving. So number 5, we could solve for y very easily, and we would get y is equal to, I'm going to write this as negative x plus 16. And you just kind of think about it. Well, for every x I put in, I'll only get one answer out for y, so yeah, that's a function. Same thing with 6. If I solve for y, I will get y is equal to 9 minus x squared. For every x I put in, I'll just get one y out. Okay? Two different x's can give me the same y. That's okay. But that doesn't break the rule. Okay, but let's look at number 7. Number 7, something strange happens. I have a y squared here. Okay, so if I start solving, I'll get y squared is equal to 64 minus x. Now, y is not solved for yet. I now need to take the square root of both sides of this equation. But what's the rule when you take a square root? Every time you take a square root, you have to include both the positive and negative possibilities. So that means this would simplify to y is equal to plus or minus the square root of 64 minus x. Plus or minus. That means if I put in x equals 0 here, oops, you can't see that. If I put in x equals 0, 64 minus 0 is 64. The square root of 64 is 8, and I would have both the positive 8 and the negative 8 as y values. Therefore, 1x gave me 2 y's, and so this is not a function. Okay? Number 8. Number 8 is a function because they put the square root symbol in, not me, and they narrowed it down to just the negative root. So that is a function. Number 9, I put number 9 on here on purpose. Cube roots do not have the same rules as square roots. Okay? When you take the cube root of a number, you don't have both a positive and negative possibility. For example, the cube root of 8 is just 2, because 2 times 2 times 2 is 8. But the cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2 is negative 8. Okay? So we don't have any weird rules with cube roots, and therefore I could very easily solve this for y, and I would end up with, let's see if you believe me, 1 minus x. Y is equal to the cube root of 1 minus x. So yes, that is a function. I'll just tell you that 10 and 11 are also both functions, and I'll let you solve those for y. Okay, let's pause for just a moment while I grab some scratch paper.